So, yeah, my scanner, yeah, the huge monstrosity that is the empty case, yeah, link and so on. A plan, we will have a look at that in detail just in a sec. A whole lot of parts, well, mainly connectors. We will see them in action, hopefully. And yeah, as you remember from the teardown, I had this. There was that power board right here with yeah, IC connector, very neatly connected, and of course the voltages provided by that board are absolutely nothing I could use for an UV exposure unit. So I had to come up with my own power board. And yeah, my trademark isolation routing. This is obviously not my first power board, not even on YouTube if you follow the channel. Obviously I'm getting proficient at power boards, PSUs, well, and that's going here. So I will only using 1, 2, 3 of the old screws. It's big enough, and yeah, let's have a look at the plan. It's a little bit more complicated than the other ones, but not that complicated. So please ignore the types on yeah, these jumpers. They're just stand-ins. So the idea is here 220 volts comes in and well, get fused, of course. So this should be phase, this should be neutral, doesn't really matter. And then it goes to another connector which goes off to a second. Just a second. You remember there was a real power switch. Not the old PSU, not a real power switch, but at least a power switch at the front. So yes, that will go to the power switch, and we will have to replace the original power switch because it was only rated for 120 volts, and I have a replacement that's exactly the same physical dimensions that is rated for 240 volts, 230 volts. So yeah, that's nice that I was able to find that. And then after the switch phase neutral. Yeah, for layout reasons I switch phase to neutral, but it doesn't really matter. Is going to one run-of-the-mill power brick. Where do I have it? The big one here. That will supply. Yeah, it's a wee bit dark, but can I focus? Yeah, 48 volts and whopping 600 milliamps at that 48 volts. That's obviously for the UV LEDs. Sorry, trying to refocus. Yeah. And yeah, that goes to 4 connectors. Because I plan to use, and I don't have them handy here, but this size Euro boards, each carrying about 50 UV LEDs. I only have currently 100 UV LEDs, but yeah, maybe at some point I really want to make, you know, a 4-sized board. I cannot imagine why or when, but if the need arises, I can put in 4 Euro-sized boards with UV LEDs on it all together. And these are switched over little cute tiny, I mean it's a TO3 case MOSFET and channel, which is usually by default in the off state through I haven't made a decision here, obviously a 5.1K or 4.7K resistor. I mean it's on or off, it will don't be modulated, so yeah, you could probably take a higher resistor, but I think that's what I got. And on the other side we are going into a quite smaller power brick. Yeah, sorry. Black on black, does it focus? Yes, 9 volts, a little over 200 milliamps. And that will actually be the supply for an old Arduino Micro, which I'm using because I don't like it, but more on that when we come to the controller board. And that goes just for power dissipation reasons through 2 run-of-the-mill 1N4001 diodes, just to drop the 9 volts a little bit closer to the 7 volts that an Arduino Micro takes on its V-in. And yeah, there are people out there who are supplying their Arduinos directly with 5 volts, but without modifying the Arduino. That has some drawbacks, and we talk about that when we come to the controller board. But today it's obviously video title. It's not the controller board, it's a power board. And that goes well, plus and of course ground to a 3-pin connector, which is a power supply for the controller board and also allows through the middle pin the controller board to switch on the MOSFET and therefore switch on, switch off our LEDs. And that should, I've already shown it, fit everything on this little board with, really a lot of isolation between the primary side, which will be here, and yeah, the relatively low voltage side, 84 volts, up here. And yeah, that should be the layout, 1-to-1, if I printed it right, just for orientation, where to put my parts. And yeah, layout from the back with the traces I have to create on the perf board, so nothing really fancy. And I guess it's time to put it together, maybe by gluing the connectors to the board. You probably have noticed that I like to glue the connectors to the board, just to give them a little bit more heft. I'll be back in a sec. So I glued the connectors on and gave it hopefully enough time to cure. Let's put these away again. And yeah, I know normally printed circuit board you put on the smallest part first, but yeah, it's a perf board and I prefer to put the major components on first, so yeah, I don't fuck up. Oh, not quite on the right angles, but that's okay. I glued on. Yeah, talking about major parts, let's start with that puppy. And that should go other way around. That's the back. Yeah, it caused me some grief because also in the layout at the beginning, because this goes in upside down into the case. Yeah, that should be somewhere, and maybe you can see it. Oops, sorry, I marked the holes a wee bit, so this should go in here. Yeah, that looks about right. I guess I will go at some point to time-lapse. And for this kind of currents, I think my smallest 0.6 millimeter silver plated copper will be more than sufficient. Yeah, I had to drill for the big one some extra holes, or enlarge the holes, and yeah, they don't fit into the two 0.1 inch raster, respectively 2.54 millimeter raster. But yeah, well. Yeah, this was also the first time I used my Proxon to route off the copper. And I routed off maybe a little bit too much. Okay, and that was all of the primary side. Mains AC comes in, is connected to hopefully AC and AC of the two power bricks. Yes, it is. and then the other AC. And yeah, I know I'm mixing live and neutral on the power bricks, but it really doesn't matter. Especially here in Europe. uh, yeah, and both go to the connector, which will lead to the main power switch, and then it goes to the fuse and back to mains AC. So let's start with the low voltage side. And I have now always look at the traces, how they should look like, and yeah, that's the reason like to take or to put the connectors in first, and the main components where I've drilled holes, so I don't get lost. Now that's the first of the 48 volt lines, the positive, and well, it's only 48 volts, but yeah, I want to keep a little distance from my 3-pin 5 volt connector here, so yeah, 48 volts is probably not something that an Arduino can tolerate, even for a short time. So that was the positive 48 volts rail, and yeah, it's looks symmetrical, then I probably did it right. Not much missing now, is it? Ah, okay. Now there's only one part left to do, and this is a tiny wee MOSFET. I mean, these MOSFETs are, I'm using here, sorry, they are quite nice. So 60 volts, 600 milliamperes, which is more than enough. and logic level switching, exactly what I need to control it with an Arduino at a later stage. The only drawback is 100 milliohms on resistance, which is for actual MOSFET technology like a lot. But on the other side, you know, at the moment I'm pulling about 180 milliamps. Yeah. So 8 strings are 20 milliamps. 8 strings of LEDs are each 20 milliamps through it. And if I ever add 2 more LED boards, it will be 300. What did I say? 80, 160 milliamps. It will be 320 milliamps, and yeah, okay. So yeah, the voltage drop even at and power loss here, even at 100 milliohms already on, is yeah, pretty negligible. I hope I did the footprint right, because that was not in the library of the package CAD package I use. So we'll see. Now 9 more of them, and it really won't kill anything if this tiny plastic blob blows up, which it shouldn't. Looks almost good. Almost. Maybe can get rid of this little blob of solder here. Oh yeah, and since I'm not using any isolation this time, maybe it's a good idea to put some, you know, just to be on the safe side, temporarily while I work on the open case. Put some isolation tape over the primary tracks. Let's do a second layer. Okay, third layer. And no, I'm not paranoid. I actually know how it feels to get hit by here European 230 volts AC, or yeah, back then when I was young, 220 volts was the norm. It's not nice. I will take it off as soon as the whole unit is finished and closed up, so in a couple of months maybe. Yeah, I think we are almost ready for testing, huh? One last look, but it seems to be okay. Yeah, but before we can test the board, and I put a fuse in it, we'll start with 1 amp slow, because the inrush current from that thing is quite high. We have to replace the power switch, because the power switch is only rated for can you read that? Probably not. Yeah, 125 volts. I mean, it was not switching mains AC, it was switching on the low side of the original. That's better, power supply. So yeah, that thing has to, oh wait, that thing has to, hey, 250 volts, 1.6 amps. Okay, so yeah, that thing has even a better, sorry, out of focus, just a second. That thing has even a better rating than the one I bought, which is only 1 amp, 250 volts. And I really struggled and searched high and low to find a switch, sorry for the exposure, that has exactly the same measurements, so I wouldn't have to, you know, fiddle around with the mechanics here. But yeah, looks like I can reuse that one. Yeah, you can never have enough switches, and that's a really nice nap-in power switch for whatever. So yeah, I just take a moment and put a mains AC rated cable on that. And okay, the on-off switch has a new cable, and yeah, as always, lots of heat shrink tubing. And the other end goes into a, well, 230 volt rated Phoenix contact connector. And for the final assembly, I may put this around. Yeah, that looks good. Now I should be able to put in the power board with ease. Hopefully. These are, by the way, the original screws. There are 3 different screws. And yeah, you don't find that in a modern product anymore because it's too costly. So yeah, my on-off switch goes here. Wonderful. Mains in goes here. Wonderful. And then we can screw the whole thing in, and yeah, it's fitting. I mean, I know it's fitting because of course I tested more or less tested. Yeah, here on this side I'm a little bit working on luck because obviously I haven't planned enough spacing for that metal strut coming up here, but yeah, it's still fitting. looks good. So I guess we are ready for some tests. First make sure that, okay, this is now out of frame. That's in the off position, and I get a meter, and we'll first test if we got 5 volts out of here. Huh? And of course we are not expecting 5 volts out of here, but 9 volts minus 2 diode drops, so 9 minus 1.2 is 7.8 volts. And 7 volts is the minimum input these small Arduino boards need. Let's change the perspective a wee bit. Okay, you cannot see everything. That's quite impossible here with my setup. But yeah. Let's connect some mains AC. Okay, no big bang. And yeah, I'm reaching back here to the power switch. And it's already saying 9.43 volts. That's a little bit discerning. And that's the 8. I have to say I'm a little bit flabbergasted. I mean, it's okay, but why is there voltage at all in the off state? I think it's off. Is there actually some leakage? Okay, now it's going down. Maybe I should have tested that damn switch beforehand, huh? Okay, so disconnected and just going on testing the switch here. Okay, that's continuity. That's not good. Oh, the power switch is working fine. Yeah, I'm switching in the background here. Okay. That's nice to know that power switch is working exactly the other way around. So, yeah, I won't try to show that, but basically, just a second. That switch seems to be, so that switch that's actually in or was in, seems to be on, off if it's pressed in, and off when it's out. Okay, somebody should have told me that. So again, now the power switch is in, pressed in, or latched in. Now it's out. Okay. Latched in, get the isolation back on. And the test leads connected back to my output. To my supposedly less than 9 volt output. What I have predicted 7.8. Oh, I should go back to volts. Yeah, it's quite hard. Okay, that looks good. So, okay, that's better. So we are now in the off state, and now I switch it on. And it goes up to a full 9 volts. Okay, give me another second. Let's put some load onto that stuff here. Yeah, so off. Yeah, and it's slowly but surely falling. Slowly, more slowly. Okay, I've shoved in here a 1K resistor. And now let's see. Yeah, 7.7. These power bricks I'm using, and yeah, they are on the back, and yeah, there's the reason I have that tape here on the mains AC tracks. Pointing on it might be stupid, but happens. Yeah, these bricks, they specify that they have a certain leakage current from the main side to the low voltage side. That leakage current is usually very, very low. But if you have a high impedance voltmeter measuring, it can really fuck off. Really distort your results. Anyway, with a 1K resistor, yeah, it's exactly what we expect. Yeah, let's go over to the 48 volt ports. 4 of them, and look what's coming out there. Okay, connected now to the 48 volts, and there is absolutely nothing. What is to be expected, because that MOSFET here is by default the gate drawn down to ground. So yeah, there should be no voltage across these pins, and it's really absolutely zero. That's good. If I now somehow short out with maybe another probe the plus line on the 3-pin connector, positive line to the gate, then we should see 48 volts or something like that. So I just shorted plus and the gate line to the MOSFET controlling my 48 volt outputs, and if I again switch on, then I have, of course, 48 volts. Wow. Yeah, wonderful. And if I remove that, we're down to 0. So that means the future controller board can easily switch the 48 volt outputs. And yeah, I didn't fuck up with the 3 pins in my layout and creating that new part and the footprint for it. Very nice. And I guess that's it for now. Next step is not the controller board, because I'm, to be honest, I'm thinking how to place that into the case. Still thinking about it, but yeah, we can manually switch on, switch off the 48 volt output. So next step will be the LED board. And till then, bye.